Hello and welcome back to my Applied Data Science channel. My name is Ioana, I'm a senior data scientist, and in this video we are going to perform exploratory data analysis as the first step into this new machine learning project. This time we are working with transactional data from online casino players. So let's get to it. First of all, we are going to import the libraries that we need. I've already created a virtual environment where I installed all the necessary packages. You can download the dataset from a link that I'm going to put in the description as well. And there is an article associated to this dataset that we are going to use in order to understand what the meaning of the variables is. I downloaded the dataset right here, so the first thing that I'm going to do is load the data. It is a CSV file, therefore I can just use panda read CSV and then pass in the path to my file, printing the first 5 rows in order to check that the dataset loaded correctly. We see that we have 5 variables, and this first column contains time data. So let's go into checking the data types. Although the first column looks like it would be a time series data, we see here that it is actually a string. So this is the first thing that we are going to do. We are going to convert the string column to a datetime object. And for that, we are going to use pandas to datetime and pass in the name of the column. And we only need to overwrite the column with the newly casted data type, and then check the data types once again to see if the change took place. Okay, that's a confirmation. Then we have the transaction type, which is a string object. Transaction amount is float64, status string, and account identifier is also a string object. Now I really want to find out more about this transaction type. What does it actually mean? So what I can do is get some summary statistics. I'm going to use the describe method. And the describe method, if we just use it as it is, by default is going to return the summary statistics of the numerical variables, which in our case is the transaction amount, which is a float64. If I want to get the description of the string variables or categorical variables, I can pass in the parameter exclude, the data type that I want to exclude from the analysis. So in my situation, I'm going to exclude the float64 variable, and then I'm going to get summary statistics for all other variables that have different data types. And regarding the transaction type here, I see that I have 3 unique values, out of which the loyalty card debit is the most frequent value. In status, I have 2 unique values, approved and probably rejected. And in the account identifier, I have 2,361 unique users of the online casino game. What I can see over here is that the last date in my data set is the 2nd of March of 2020, and the first date of my records is the 1st of March 2019. Given that I'm supposed to have data for only 1 year, the maximum value should be the 29th of February. So I'm going to first exclude these observations and then go back to transaction type. When we have a datetime object, what we can do in order to compare dates is just use the normal operators, greater than or lower than. Okay, so if I just do this comparison, I can see that for the majority of observations I have a false, but I also have a true. So probably at this row ID, there is a person who deposited money outside my range. So I am going to exclude all these observations, all these rows for which the value is true. That is, for which the date is above the 29th of February 2020. And how can I do this? So I'm just going to keep all those observations for which the date is smaller. And I'm overwriting the data frame and creating a copy of this. Okay, so now let's check once again here in the describe, and now indeed we see that we have a lower maximum date over here, so our change worked. Okay, let's go back to the transaction type. As I can see from here, there are 3 unique values. Let's see exactly what these unique values are. So the unique values are loyalty card debit, loyalty card credit TCL, and loyalty card credit. Now I want to go to this article that I was telling you about. Okay, so over here I have the data description, and in the data description I am hoping to actually get some information. So we are working with the online casino DIB CSV file. Okay, the time UTC is the transaction timestamp. Transaction type includes loyalty card debit are level 2 deposits, loyalty card credit are level 2 withdrawals, and then we also have level 1 deposits made via card or ECH. The transaction amount is the transaction in US dollars. Then we have the status indicating whether the transaction was approved or declined, and the account identifier identifying the customer who made the transaction. Okay, so back to the transaction type. Here we have a diagram which tells us that level 1 deposits and withdrawals happen from the customer's funding account or the bank account into a digital wallet. And then from this digital wallet to the gambling's account or the customer's wagering account, all transactions are called level 2. So level 2 deposits and level 2 withdrawals. So then the flow of the money is from the customer's account to the digital wallet, and from the digital wallet to the platform, the online casino platform, where the customer can actually start to gamble. Good. So then let's give just more intuitive names to our loyalty card, debit, credit, and so on. Because this way we are going to have a better intuition of what we are working with. So I'm going to extract these unique values from here. And I'm going to create this dictionary in which these old values, these will be the old values, and I am going now to think how to rename this better. So as the values, I'll pass in the new values that I want to replace the old ones with. Now what I can do is map the old value to the new value by using the function map. So now I can see that my column contains the newly defined values, and I'm going to also replace it. So overwrite the column, and there it is. Now I can check again the describe, and I can see that here I'll have L2D, so that changed. Now that we've cleaned the data set a little bit, let's go on and create some visualizations in order to understand the data. In our data set we have both deposits and withdrawals of money, and I would be interested to see actually if the number of times people deposit money and the number of times people withdraw the money are very different or not. And I want to check that by customer. So I want to group by account identifier, and then I want to count the number of transactions. What this actually does is counting the number of rows for each one of my customer. And given that each one of the rows in the data frame is a transaction, either a deposit or a withdrawal, then I can simply have the total number of withdrawals, deposits, like the total number of transactions. So if I want to get the total number of transactions by transaction type, I would also need to include here in the grouping list the transaction type variable. And I can see here now that I have two grouping variables. So first of all, I have the customer as before, but now I've separated the transaction counts by the type of transaction. And this is exactly what I'm looking for. I can convert these grouping variables into regular columns by just saying reset index. This is going to bring them back in my data frame as regular variables. And now what I can do is actually create a histogram in order to check the distribution of transactions. So I'm going to save this object. And now I can use the seaborn, which is SNS hist plot. I'm passing in the data, which is the name of my data frame. Then I need to pass the variable x, which is going to be, in this situation, any of the variable names over here, request time UTC or transaction amount or status, because they all encode exactly the same information. So probably when you are performing like a real life project, you would like to rename these columns in a more informative way or exclude the unnecessary ones. And then we also need to specify the number of beans that our histogram should have. Okay, and we see here that we have a histogram with all the transactions. Now, if we want to check the transactions by type and then actually have 3 different histograms, we need to pass in the hue parameter the name of the column on which we are going to separate our histogram, which in our case is actually the transaction type. This is going to give us 3 different histograms. Okay, they are not really visible out here. So what can we do to get a better intuition of what's actually inside this data? So instead of creating a histogram plot, we can twitch it a little bit and actually get a cumulative distribution. Okay, so this is actually what we are looking for. So here we have the density, which indicates that level 2 deposits follow level 1 deposits really closely in terms of how many they are. And then we have this big difference between the deposits and the withdrawals. We are only going to keep for further analysis the level 2 deposits of the approved transactions. We are going to pass in 2 conditions with an AND operator between them. So we are going to select only those rows for which the transaction type is an L2 deposit. And because we have 2 conditions, we need to put them in brackets, each one of them separately. And then the second condition is that the casino status is approved. So we are just looking at those rows which had L2 deposits that were approved. Then with casino shape we can check the numbers of rows that are left and the columns. What this plot makes me wonder is, are those people with very high number of transactions the same as those who place very large amounts of money into the online casino? So let's check that. So starting from our data frame, what we would need to do is first of all check which are those top 20 people who are the most frequent gamblers, right? So I want to group my data frame by account identifier, and I want to get the number of transactions that each person made throughout the year. And given that I've already selected only the deposits, so now I have only a data frame with the deposits, I'm only going to count the number of rows I have for each one of my customers. And this is going to give me the number of transactions per customer, or the number of rows I have in the data frame per customer ID. Now I want to bring back this column as a regular column, so I'll reset the index, subset the first two columns over here. So I'll use the index location, selecting all the rows and just the first two columns. As I can see from my data frame right now, it is not very intuitive which are those customers with which transactioned the most. So I would need to sort the data frame by the number of transactions. And how I can do that is by using sort values, and then inside here passing the name of the column that I want to sort by. Okay, so now my data frame is sorted. I want to reverse and start from the most frequent customer. And now I'm only going to select the first 20 who are the most frequent depositors. I need to check the top 20 spenders. Basically what I'm doing over here is I subset from my data frame only the information from these two columns. Then I'm grouping by account identifier, summing up the values in the remaining column. That's transaction amount. And then again, as before, resetting the index, and this is done just to bring back the grouping variable to a regular column. And then I'm going to drop this iLock because I don't need it anymore. That's just subsetting columns, but I've subsetted my columns over here already. And I'm sorting the values. Here, the sorting column is going to be the transaction amount. And then I'm going to reverse the values. And let's see if the top 20 spenders are what we are expecting them to be. And indeed, we can see here that we have the sorted data frame with the people who spent the most amount of money. Okay, so let's visualize this. We are going to visualize this information side by side, and for that I'm going to use the subplots method. By passing in n columns equal to 2, what I'm actually doing is creating two empty slots in which I'm going to later place my bar charts. The first bar plot is going to be that of the most frequent 20 spenders. Then here, account identifier, I'll have to pass in a parameter to specify the location in the slots where I want this first bar plot to be. Let's go on and also display the second bar plot, but this time I'm going to use the top 20 spenders. In X, I'm going to place the amount of money, so the transaction amount over here. And on the Y-axis, I'm going to leave the user ID or the customer ID. And then I'm going to specify the axis on which I want this second plot to be displayed. Set a larger figure size with the parameter fixed size, and I'm just going to first pass in the width and then the height. And now I have two very nice looking bar plots which tell me actually that those customers who are the most frequent gamblers are not the same as those who spend the most amount of money during online casino gambling. Okay, so this is really nice information, right? Until now, we haven't worked with the datetime objects at all, so let's see a little bit what we can do with them. So first of all, let's identify which is our datetime variable. The first thing that we can do with this type of variables is extracting the year, the month, the day, the hour as integer values. So we could, for example, say extract hour. There are other things that we could extract. For example, we can extract the day of the week. The day of the week is also a numerical value with 0 meaning Monday and 6 meaning Sunday. Store this information in our data frame, create a new variable called day of week, and the same as before, we are also going to create a new variable called hour. I don't want to have in my data frame under day of week numbers, but I would like to have strings indicating the exact day of the week, Monday, Tuesday, Thursday, or so on. And for that, what I'll have to do is map the values of the current day of week, so 0, 1, 2, to the values that I want them to be substituted with. And for that, I am going to use once again the map function, and inside the map function I'm going to pass in a dictionary. So I can just pass in this object, and now let's see how our data frame looks like. Okay, so I've added the day of the week and the hour. What I want to check next is, are there any patterns in terms of the time of the day when the gamblers are more active? And in order to do that, I can create a very nice heat map. But to create a heat map, I need my data to be stored in a different way that it is right now. So I'll need something like a confusion matrix with the days of the week as the indices of my rows and the hour of the day as the columns of my rows. So, of course, as you can see over here, I don't have that. So the question is, how do we go from what we have over here to what we need to create a heat map? The first thing that I need to do is to group my data by hour and the day of the week. And for each pair, day of the week and hour, I need to count the number of transactions, the number of deposits that are being made. Let's just extract the variables that we need. So we need hour and the day of the week, because these are the variables that we are going to group our data on. And then we are going to use also, let's say, transaction type as the third variable. So this is the base data frame that we are going to group. So from here we go and group by two of our variables. Those are the hour and the day of the week. We are going to place them inside a list, and we will count all the values for these particular pairs. And here we have our grouped data frame. We are now resetting the index because we want these grouping columns to go back to their regular status. And we can see that here we have pairs of day of the week and hour. So this is the data frame that we need to convert to the confusion matrix that we have over here. Use the pivot table function from pandas data frame, and inside this pivot table we are going to pass first the name of our original data frame. Then we need to specify under which of these columns our values are stored. So our values are actually the values that are at the intersection of each row index and column index. And those are under transaction type. Then we need to specify the index, and this refers to the row index. So that's under day of the week. And finally, we need to specify the names of the columns. And the name of the columns over here are under the hour. So let's see if we've achieved what we wanted. Now we can pass in this object, this data frame, inside our seaborn Heatmap function in order to create a really nice visualization. So this is the Heatmap, which shows us which are the times of the day when users are depositing most frequently. Let's go into more detail in terms of daily activity. So first of all, in order to analyze at day level, we will need to create a new variable that is just going to contain the days. So discard the time of the day, discarding the hour. And we are going to use toPeriod to discard the time. Okay, then I'll show you how this looks like. As you can see over here, we don't have any information regarding the time within a day, but we just have the days. To have a better intuition on the daily activity of a customer, there are two things that I can check. How many deposits a customer did within a day, and also summing up to what amount. And for that, I'll need to group my data frame by count identifier and date. And then I'll have to calculate two measurements. One will be the number of times a person deposited money, that will be just the number of rows, and also the overall amount that was deposited throughout the day. We need to aggregate more than one variable, as in our case, I'll have to aggregate transaction amounts and also number of deposits. I can use the aggregate function. So first of all, I'm going to group my data frame. So the first column that I want to aggregate on is the transaction amount. So I'll pass it in here as the key into my dictionary. And the value is going to be the function that I'm going to use for aggregation, and that's going to be sum. So this is going to sum up all the activity or all the amounts for each user every day. The second metric that I want to check, it's going to be a count. And again, it can be the count of transaction type. I didn't see that I have put there the square brackets twice. Okay, so this is going to be my aggregated daily activity. What I can do now, so I'm not sure if you are aware, but if you put this backslash over here and go on the next line, you can continue your function and at the same time have everything like really visible and not stick out of the screen. So you can reset the index now in order to bring back the columns up there. So we can see over here that for each customer we have its daily activity. So how much money they spent every day, how many times they deposited money every day. Let's put this into an object that's called daily activity. And now let's subset the first customer and see exactly what this daily activity means. So now I'm going to check exactly its daily activity, and what sticks out here is that between the 17th of March and the 29th of March there was no activity. If we tried to create a line plot to display the transaction amount or the number of transactions, we could not do that. And let me show you that what I'm talking here is actually correct. So let's call this C1 from customer 1. We want to show the days on the x-axis and then the transaction amount on the y-axis. And we get a type error. And then this type error is raised because, as it says here, how to handle missing values. So we need to make sure that we fix these gaps in our data. So let's start to fill in those missing gaps for one customer and then see how we can continue with the rest. This is the data frame for customer 1, and what we need to do is to check which is the first date when the customer deposited money and which was the last date when he did so. And with that information, we are going to build the full range, filling in those dates that are missing. The full range of dates can be generated with the date range from pandas. We'll have to simply specify which is the customer df required date minimum value, and then exactly the same with the maximum value, and then we have to specify the frequency to be the day. And now let's check our full range. And we see that it is a date-time index. Now, in order to be able to replace our dates with this range, what we need to do is to reindex our data frame. So currently the customer data frame, if we check it, has this numerical index. We will have to replace this numerical index with the date-time index in request date UTC. For that, we are going to set the index to be this new column. Okay. So now we see that here we have our newly created index. And once we have done that, we can replace this index or enhance this index with the full range of indices, which is also a date-time index. So we will use the function reindex, and then we will pass as a list this full range of date-time indices. And then there is a parameter fill value which asks us what's the value that should I put inside all the other columns when you don't have information for this particular index value. So we say put 0. The transaction amount and the transaction type for those dates when we don't have values equals to 0. But also the account identifier equals to 0. Populate the account identifier column with the ID of the customer. This is the customer ID, and we are creating here a vector of customer IDs only with the length of our data frame. This should have solved our problem. And now in customer data frame, we see that we have customer 1 everywhere. And then we have zeros in the transaction amount and the transaction type where we don't have observations. We have multiple customers. So how can we address them all? We need a data structure where we can put together all these individual customer data frames. I'll call it full customer data frame. This is a pandas data frame and it is empty for now. For customer ID in, and here I'll need to specify a list with all the customer IDs that I have inside my data frame. So I'm going to use my daily activity data frame, and I'm going to use the account identifier column because that's where I have the customer IDs, and I'll create a vector of unique customer IDs. And so I'm going to iterate through this list of unique IDs, customer ID for customer 1, and I'm replacing it here. Then customer 2, and so on. So these are the places where we need to replace the customer ID. And at the end, we are going to have this customer data frame. So how do we store this customer data frame in the full customer data frame? At each iteration, we are going to recreate the full customer data frame by concatenating what we had until now, so the existing full customer data frame and the newly created customer data frame. Another thing that I've just noticed right now is that I've left the required date UTC to be the index of the data frame, but actually I want to put it back as a regular column. So I'm going to reset the index also for my newly created data frame. Okay, I have a problem right here. I didn't say full customer data frame, and now it should work. This is my full customer data frame where I have the transaction amount and the transaction type by customer by day. So the missing slots. Now that I've done that, I want to see what's the flow of my customers throughout the year. When did they start gambling? When did they stop gambling? Or if they continued throughout the year to immerse themselves in this online casino universe. To do that, I would like to visualize the data in a special way that I haven't seen people visualizing it before, and that's by creating a Sankey diagram. And the Sankey diagram, once again, needs to have the data structured in a particular way. So we need to have a starting or a source node, then a target node, and then we need a value, a number. So in our situation, the sources are going to be the months of the year when the person started to gamble. Then the target nodes are going to be the last month of the year when the person placed a deposit. And then here the values are going to be the number of customers that started and finished together. We were talking about the source and targets being the months, so the month is going to be our period of reference. So now we are creating a new column which only includes the months, and we are going to put it in the full customer DF under the column month. What we need now is to extract all the months when a customer deposited money. And here we are going to group by month and account identifier. We are resetting the index to bring our grouping variables back up, because actually this is the only information that we need. We don't need counts or anything. We just want to see the pairs between customers and months. So I'm going to slice this data frame and only select the first two columns. So now we have here month and account identifier. Okay, what I want to do next is to see which is the month in which my customer placed the first deposit, the first money, and I'll consider that to be the month when he placed the first bet. And then what's the month in which the customer placed the last bet or deposited money last. And then I'll have an intuition of the starting and the ending months of gambling. Group by customer. Then extract the minimum value, and then I can do exactly the same with the maximum month, which is just going to return the last month in which a customer deposited money. Create a new data frame with 3 columns, out of which on the first column I'll have the account identifier, then I'll have the starting month, and finally I'll have the ending month of money depositing. And for that, I can use from pandas the function merge. And with merge, I can put together 2 data frames. So I'll start with the start data frame. Then I'll want to add the end data frame information next to it. And I want to merge these 2 columns by account identifier. So this is named exactly the same in both of my data frames, start and end. So now I have created this new object over here. I'm going to call this start and data frame. Now I have my starting month and my ending month, but I don't have yet the number of customers who have exactly started and ending depositing money in the same months. So in order to do that, probably you're already anticipating I will have to perform a group by operation again, but I'll have to group by these two variables here, the starting and ending month, and then count the number of users, of customers in each one of the start and month pairs. And this is going to be actually my source, target, and value data frame. Let's call it like that. A Sankey diagram won't allow me to pass in datetime objects or string objects as the source and the target values, so I will have to encode them into numerical values. We can use the label encoder from sklearn. And this is going to allow us to fit transform any type of string data to numerical data. We want to fit transform all the unique values in the starting month and respectively in the ending month. So let's pass in the source, target, value. This is our data frame. Now we are selecting the column month X, and we want to extract all the unique values. We'll just have to actually say label encoder. Source target value is not defined. Source target. Okay. Now I have all my transformed labels, and now I can finally go on and create my Sankey diagram. I'm going to just paste in the code over here. So what I'm doing is, or what's most important, is these three parameters, source, target, value. I'm passing in the columns from our source, target, value data frame. So month X is going to be the source, and I apply the transformation such that instead of having datetime sources, I have numerical sources as I defined them here. And then the same I'm going to do with the target. So I'm passing in the column for target, and then I'm passing in also the column for the values, which are actually, if we check here once again, it has the name account identifier. We have this Sankey diagram, and at the same time we see that we have some rings over here. Those are the people who started and stopped depositing money in the same month. So we can call these people fast quitters. Let's extract all those people from our source target data frame. These are the people who deposited money first, the same month as the last time they deposited money. So we can call these people the fast quitters. So now we want to actually keep in our source target value data frame only those people which don't have equality between the source and target months. So we are going to specify the inequality over here. And now if we run the Sankey diagram again, we see this very beautiful flow chart. And the first thing that pops to our eyes is that at the beginning of the year, so March 2019, there were 467 people who placed bets, but this number decreased over the time to 344. So there is a descending trend, as it seems. Then each one of these ribbons indicates the flow or the life cycle of one customer. So here we see all the people that started to place bets in March 2019 and stopped placing bets in August, the 8th month of the year. If we look over there, for example, these are the people who started sometimes in the middle of our period, so in September here, and continued to place bets throughout the year until our last observed month, and so on. And these are the very constant people and loyal clients who deposited money throughout the year. So I think this is a very nice visualization to give a good intuition of how the clients flow throughout the year and how do they bring their contribution in the end to the revenue of the company. I have previously created this customer by month. I have all the months when each one of the customers deposited money. I can count the number of customers I have each month by using group by month and count. And then I also have the fast quitters over here, which are the number of customers who deposited money 1 month only. So I'll have actually to merge these two data frames, these two information. So first of all, I'm going to subset number of columns month X from fast quitters and account identifier. Okay. So I've saved this into objects. Let's check once again how each of these objects looks like. So this is the total number of customers which deposited money every month, and these are those people who only deposited money during 1 month. So I'll have to merge these two information once again. How do I do this? Well, I'll just use the merge function again from pandas, and so I can do pandas merge. This is good practice to do some data wrangling. Okay, so here we want to reset the index. So now we have month and account identifier, and here we have month X and account identifier. We want to merge these two data frames by month because we need the monthly number of people. So because the two column names don't match, what we can do is say right on and left on. So in right on, we are going to put the name of the column based on which we are going to do the merge, and the name of the column has to be on the right hand side here in the data frame. So the rightmost data frame is fast quitters data frame, and we'll have their month X. So on right on we are placing month X, then on left on we just have month. That's the name of the column of the leftmost data frame based on which we perform the merge. Okay. We don't need all the information over there, we only need to extract the month, and then we'll have the account identifier X, which is the total number of people who deposited money, and then the account identifier Y, which is the number of people who quitted fast. Let's put this into an object. Let's rename the columns and then check how this looks like. Okay, so we have the total and the quit. So now we want to create a grouped bar chart. We have the month, we have the total number of people that deposited money every month, and then we have the total number of people who quit exactly the same month. So for a grouped bar chart, we will need to convert the column names to a categorical variable with each row containing one category, quit or deposit. So how do we go from this to this? There is a really nice function that helps us achieve that. It is called meld. So we are going to pass in our data frame and use the melt function, and in melt we are going to pass in the ID vars, but the column that we want to keep as an ID variable, that's going to be month. Simply what we needed in order to put the other two columns as categories inside a new variable. We can create a nice plot, nice visualization with this. We can create a grouped bar chart. Let's first create the figure and an axis and define the figure size to be 15.5. And now let's simply create a seaborn bar chart. Okay. On the x-axis we are going to put the month. Then on the y-axis we are going to put the value. And then we are going to color code our groups, so the hue is going to be the variable. Ta-da! So this is our grouped bar chart. Okay. So from this exploratory data analysis, I can already pinpoint two use cases that we could solve with this data. So first of all, we could use the data to create a segmentation algorithm of our customers, so we can identify different customer profiles, different gambling typologies, practice unsupervised learning, and try to find different segments of customers. And then the second use case that I would like to work on is try to predict whether a customer is going to deposit money within the next period of time. So this is more suitable for a churn analysis project. Which of these two use cases would you be more interested in tackling next? Would it be a segmentation, a clustering analysis to practice unsupervised learning, or would it be a churn analysis in order to predict the chances of a customer churning the service? If you would like to learn more about applied data science, and if you would like to see more of these type of tutorials, then don't forget to subscribe to the channel and spread the word with your friends as well. Hope to see you next time.